Welcome back to the deep dive. This is where we take, some of the most complex technical stuff out there, the kind of thing that makes your eyes glaze over in a manual, and we try to turn it into simple, actionable knowledge.
Yeah, that's the goal.
And today our mission is, it's really laser focused. We're looking at the basic data setup, the architecture that anyone just starting out in DevOps really needs to know, especially inside Google Cloud.
And we get it. Diving into these cloud concepts, all the tools, it can feel like a lot. It's overwhelming.
Totally.
Especially if, the terminology is new or if English isn't your first language. So our goal today isn't just to give you a list of tools. We want to explain the why. Why do these pieces exist? And more importantly, how do they all connect to solve some really common problems?
Exactly. The why is everything. We've been looking at two scenarios that, every single engineering team, every finance team, they have to deal with this stuff. First, how do you actually analyze the performance of your systems over time? And second, maybe more importantly for the business, how do you track where all the money is going? Our sources kind of lay out the blueprint for this, and we're just going to walk through it.
Yeah, for this deep dive, we're really going to zero in on 3 key tools in Google Cloud. First, the Cloud Operations Suite. We're mostly talking about the logging part of that. Then BigQuery. And finally, Looker Studio.
Okay.
And we're going to tie all that together with one really crucial idea for managing costs, and that's labels.
Okay, so to make all of this really stick, let's use a metaphor right from the get-go. I want you to think of this whole data process like you're running a huge, really detailed library.
A library. I like it.
So our main tool for storage and analysis, that's BigQuery. Let's call that our secure, massive, and super organized warehouse, or, the library itself. This is where all the heavy lifting, the serious analytical work gets done.
Okay, so if BigQuery is the library where we're doing all the deep research, what's Looker Studio?
So Looker Studio, that's the beautiful art gallery next door. Or maybe it's the personalized report card. It's the friendly front door where we take all those, complicated findings from the library and display them simply.
So that anyone can understand them.
Anyone. The CEO, your product manager, they can just walk in and get the picture instantly. No deep research required.
That makes a lot of sense. A great way to frame it.
I think so. So let's start with that first big challenge, the one that kicks off this whole data pipeline. What is the problem we're trying to solve with all this performance data?
Okay, so the first scenario is all about scale and summarizing things. So you're storing all your system history. Specifically, we're talking about virtual machine or VM utilization logs in the cloud.
Okay.
The business comes to you with a tough request. They say, we need to turn this constant, tiny stream of raw data into a clean, interactive report.
That sounds hard enough already.
It gets harder. It has to update in real time, but, and this is the key part, it only shows the data summarized or aggregated on a quarterly basis.
Wow. Okay, so that is a huge translation job. You're going from, maybe millions of tiny data points every minute to just 4 big numbers per year.
Exactly.
That means you have to move data, filter it, add it all up, and then make it look good.
Yeah.
So let's start at step 1. Where does all of that raw, messy history even come from?
That's the perfect place to start, the source.
Well, let's establish our starting point. Before we can analyze anything, we have to capture it, right?
Yeah.
And in the tech world, you can't get away from the word log. So for anyone new to this, let's just break it down. We have a virtual machine, a VM.
Right.
What is that? Super simple.
Right.
It's basically a computer inside another computer running in the cloud.
Yep. And that VM, just like an employee doing a job, is constantly creating a record of its activity. Every single thing it does using a bit of CPU power, accessing memory, it generates this tiny digital receipt, a time-stamped note.
And that little note is a log entry.
That's it.
And what's crucial here is the speed, right? These log entries are being created at just an incredible rate. They are the system's automatic history book, written in real time.
And the tool that's responsible for collecting the endless flood of information is part of what Google calls the Cloud Operations Suite. We're really just focusing on the part called logging.
Okay.
And its main job, its only job really, is high-speed, durable ingestion. Think of it like a super fast sensor that's always on.
Okay.
It's just capturing the raw, messy, moment-by-moment activity of everything running in your cloud environment. It's the absolute truth of what your systems are doing right now.
So we've got this huge, growing pile of receipts. Our raw logs, and they're super important. They have every detail you'd ever need for, say, fixing a problem. But here's the issue, and it's the issue that forces us to build this whole pipeline.
What's that?
Raw logs are completely unreadable for a normal person. A stakeholder, a manager, they can't make heads or tails of it, especially if they just want a summary.
Absolutely not. The analogy is perfect. Trying to figure out your quarterly spending by looking at a giant shoebox full of every single receipt from the last 3 months, it's impossible.
Yeah, it's too much.
It's too much data, it's too complex, and it just doesn't have that high-level view you need for any kind of business analysis. We need structure. We need to be able to handle the sheer scale of it.
Okay, so that brings up a really important question, I think, for beginners. Why can't we just analyze the data right there in the logging service? It's already got the data, so why do we have to move it somewhere else?
That is a fantastic question, and the answer really gets to the idea of specialization, different tools for different jobs. Cloud logging is built and optimized for one thing, getting data in fast and letting you do immediate short-term troubleshooting.
Okay, so like if a website goes down.
Exactly. If the site goes down, you want to jump into logging and see the last 5 minutes of activity right now. You need that speed. But when you need to run these really complex long-term analyses, like summarizing 3 months of CPU usage across, say, hundreds of machines, that's not what logging is built for.
So it'll be slow or expensive.
Both. If you try to query 3 months of raw data directly in the logging interface, it could be painfully slow and, yeah, potentially very expensive, especially with a ton of data. The system is designed for quick surgical strikes, not for, massive historical reports.
I see. The scale of the question changes the tool you need.
It's all about the scale, and that forces us to make this first big move in our pipeline. We have to get the data from the capture service, the place that's good at grabbing it over to a dedicated analysis service, a place that's good at, well, thinking about it.
And there's a technical term for that move, isn't there? A sync?
Yeah, you'll hear that a lot. A sync or an export filter. You basically set up a rule. You tell the system, hey, any log that has to do with VM performance, I want you to automatically send it or sync it to this other location.
Okay. And our source material is very clear about where that other location is.
It is.
Yeah.
The very first step in the correct solution is always export VM utilization logs from Google Cloud Operations Suite to BigQuery. That is the foundational move. You're taking the raw receipts from the collection box.
The shoebox.
The shoebox,
Good.
yes. And you're moving them over to the special warehouse where the heavy-duty sorting and the complex math can happen really cheaply and really fast.
This makes the division of labor so much clearer. Logging's job is just to record the data safely. Once that's done, its job is over. Now the analysis engine needs to take over.
Right. And one last point on that. It's still a good idea to keep, maybe the last 30 days of logs in logging itself. For that quick debugging we talked about.
For emergencies.
For emergencies, exactly. But for that long-term storage and the quarterly report we need to build, moving that data to BigQuery isn't just about saving money. It's an architectural necessity. You have to do it to meet the requirement. BigQuery is designed from the ground up to do math like quarterly averages on, well, petabytes of data.
It really does sound like we're moving from a recording studio that's all about speed and capturing the moment into this highly organized, massive data processing plant.
That's a great way to put it.
So let's go inside that plant.
Let's do it.
Okay, so this is the core tool for analysis. Our data has been automatically exported from logging, and now it lands right in BigQuery. And going back to our metaphor, BigQuery is our secure, huge, and really well-organized warehouse, our library.
Yep.
The amazing part is that it's serverless, which just means you don't have to worry about the computers it runs on. It's just there. And it's built to handle enormous stacks of information and answer complicated questions about it incredibly fast.
And its job is so much more than just storage. It is the analytical engine, the powerhouse. Once the logs land in BigQuery, they're usually put into these clean, structured tables.
Right, so it's not just a pile of receipts anymore. It takes those messy log entries and puts them into neat columns. This column, the time, this one is the CPU usage, and so on.
Precisely, and that structure is so important. But the most critical thing it does for our scenario is aggregation. Remember the requirement.
Data aggregated on a quarterly basis.
Exactly. This is what BigQuery was born to do. It can look at millions of rows of data that say, at 1:00 p.m., the CPU was at 80%, and instantly turn all of that into one single summary row that says, the average CPU usage for Q3 of 2024 was 62%.
Okay, that's the magic trick. How does it do that so fast and, so cheaply when you're dealing with billions of rows of data? That seems like the hardest part.
It all comes down to some really clever internal tricks. When data, especially time-based data like logs, comes into BigQuery, engineers will almost always set it up using something called partitioning, or sometimes clustering, usually based on the date.
Can you break down partitioning for a beginner? What does that actually mean?
For sure. Think about our library metaphor again. A huge library doesn't just throw all its books into one big pile, right?
Oh, that would be chaos.
It's organized into sections: history, science, fiction. Partitioning is the same idea for data. If you partition your log data by date, let's say you create a separate digital box for every single day, it has a massive impact.
How so?
Well, when you run a query asking for Q3 data, BigQuery is smart enough to know it doesn't need to look at the boxes for Q1, Q2, or Q4. It only opens the files for July, August, and September.
Ah, so it's not searching the whole library.
It's not searching the whole library. It dramatically cuts down the amount of data it has to scan, which makes the query, exponentially faster and way, way cheaper. Because BigQuery's cost is often based on how much data you scan.
That's a brilliant insight. So for our specific quarterly report, setting up that date partitioning from the start is the key technical step that makes the whole thing work at scale without breaking the bank.
Absolutely. And when you run that summary, that aggregation, you're using standard database language SQL with commands like group P by Y. You tell it to group P by Y the quarter and the year, and it just does the math for you. It's built for exactly this kind of question.
Okay, let's bring in some of that productive friction we like. One of the wrong answers in the source materials suggested, just exporting the data to a simple CSV file, a spreadsheet file, and then using Google Sheets.
Ah, the classic spreadsheet approach.
Yeah. To a beginner, that might sound way simpler. So why is that approach just fundamentally broken for this kind of DevOps problem?
It fails on, let's see, three main things: scale, real-time updates, and just general reliability.
Okay, let's take scale first.
Scale. Modern cloud systems generate a ton of logs. You'll blow past the limits of Google Sheets or any spreadsheet program, probably in the first hour. You just can't load petabytes of data into a sheet. It's like trying to fit the entire library into a single filing cabinet.
And what about real time?
A CSV file is a snapshot in time. It's static. The second you download it, it's already old news because new logs are still pouring into the system. So you're stuck in this horrible manual loop of downloading, importing, recalculating. It's just a nightmare to maintain.
And I'm guessing the third one, reliability, ties back into that manual process being so fragile.
It does, and you just don't have a standard repeatable process. BigQuery gives you a live, structured connection to that incoming data stream. You ask a question, you get a fresh, reliable answer instantly. Trying to do that by hand with spreadsheets is just, it's a recipe for failure.
We also saw another option that mentioned exporting logs to cloud storage, just a simple file storage, and then building a custom application to read them. Why is BigQuery a better choice than writing your own code for this?
That's the classic build versus buy debate in tech. Cloud storage is fantastic for just storing files cheaply, but it's not a database. It's not an analytical engine.
It's just a hard drive.
It's just a massive hard drive in the cloud. So if you put your logs there, you still have to build the whole application that knows how to read them, how to run queries, how to manage all the computer power for those queries. You're basically rebuilding BigQuery from scratch.
Which sounds expensive and time-consuming.
Terribly. BigQuery is the ready-made, off-the-shelf solution. It handles all that complexity for you. For a DevOps team trying to solve this very common problem, it's just the simplest, most powerful, and honestly the most economical way to get to your answer.
So to really nail down the takeaway for this section, BigQuery isn't just a long-term storage box. It's the specialized lab where we do the heavy, scalable math, that quarterly aggregation, and we do it efficiently by using smart techniques like partitioning.
Exactly. We've done the hard work, we've crunched the numbers.
And now they're all ready for prime time.
Now we have to face that final challenge. How do we take these clean but still complex numbers and turn them into something a non-technical leader can actually use?
Right. We've gone from raw capture and logging to complex aggregation in BigQuery. We've got our clean quarterly summary numbers sitting at a table. But like we said at the beginning, you can't just send a spreadsheet of query results to your boss.
No, that won't go over well.
It doesn't meet the requirement. So we have to move from that complex data to simple visual insight.
And this is where Looker Studio comes in. It's the essential third piece of the puzzle. If BigQuery is our detailed library where all the research happens,
then Looker Studio is our art gallery, or our report card.
Exactly. Its one and only purpose is to take that structured data from BigQuery and make it, as you said, friendly and understandable for stakeholders.
It's the translation layer. It translates from the language of the database, SQL, into the language of business, which is, graphs and charts and simple dashboards.
And if we look back at the requirements from the source material, Looker Studio is basically built point by point to meet every single one of them.
Okay, let's walk through those. The first one was that the report needed to be interactive.
Right. A static picture of a chart is okay, but it's not great.
Right.
What if a stakeholder sees a big spike in usage in Q3? They're going to want to know why. They need to be able to click on that spike and say, filter the whole report to see just the data from a specific region.
And Looker Studio lets them do that without ever having to write a line of code or even know that a database exists.
That's the whole point. It gives them simple drop-downs, sliders, date pickers, and behind the scenes, those controls are rewriting the BigQuery query for them. The second requirement was that it needed to be easy to share.
Which is huge in big companies.
It is. Looker Studio dashboards are basically just websites. You share them with a link, just like a Google Doc. You can control who sees what. It makes distributing these key metrics really simple and secure.
Okay, I have another one of those friction questions, though. BigQuery itself, in its own web console, has some basic charting tools. I've used them. They're pretty good.
They are.
So why do I need this whole other tool, Looker Studio? Why not just use the charts right there in BigQuery?
It's a really common and fair question. It comes down to the difference between analysis and presentation. The charts inside the BigQuery console are for the analyst, for the engineer.
For me, to check my work.
Exactly. They're perfect for you to quickly see if your query did what you thought it did, but they don't have the polish, the customization, the branding, the user experience that you need for a C-level executive or a broad business audience.
So an engineer uses the BigQuery chart to make sure the math is right, but the stakeholder needs a polished dashboard with the company logo, helpful titles, and clear instructions.
Precisely. Looker Studio is all about that last mile of data delivery, presentation quality. And that brings us to the third critical requirement it meets: real-time updates. This is where the whole pipeline really sings.
Okay, explain the real-time part again, because that can be a tricky concept.
Yeah.
Is Looker Studio making a copy of the data and storing it?
No, and that's the beauty of it. It doesn't store the data at all. Looker Studio is just a visualization layer, a front end, that has a direct live connection back to BigQuery. So when a user opens a dashboard or clicks a filter, Looker Studio just sends a new question, a new query, straight back to BigQuery. And since BigQuery is always getting the latest logs from logging, the dashboard automatically shows the freshest numbers possible. No manual refresh needed.
That completes the whole pipeline from the source material then. It's this clean, standard, and really efficient cloud architecture: ingestion, analysis, and presentation.
Let's just run through that three-step blueprint one more time, because this is really the core pattern for so much analytics work in the cloud.
Okay.
1. Capture. Cloud operations logging grabs every detail of what your systems are doing.
2. Analyze and aggregate. You export that raw data to BigQuery, you use partitioning to make it fast, and you use SQL to summarize it into those quarterly numbers.
And 3. Display and share. You connect Looker Studio to BigQuery to build that interactive real-time dashboard, and then you share a link with everyone who needs to see it.
That gives us the architectural clarity we were looking for. This pipeline turns that messy machine history, which is critical for engineers, into real business intelligence, which is critical for leaders.
Yeah.
And we did it without any clunky manual steps or custom code.
Exactly. We have officially mastered performance tracking, so now we have to flip the coin and look at the other side of DevOps, which is often a lot more sensitive. Money. How do we track our costs?
All right, let's get into the second big challenge, the money question. We're moving into the world of FinOps, which is financial operations. For listeners who haven't heard that term, what exactly is FinOps in this context?
FinOps is a huge and growing field. It's all about bringing, financial accountability to the way we spend money in the cloud, which can be really variable.
Right, it's not a fixed cost every month.
Not at all. In simple terms, it's about helping teams make smart trade-offs between speed, cost, and quality. If you can actually see where the money is going, you can make better decisions. It's really the intersection of finance, tech, and the business itself.
Excellent. So the scenario we have is a classic FinOps problem. We're managing a few different production systems. Let's say we have an internal CRM, a public website, and a big data pipeline. And they're all running on separate VMs.
Yeah.
But they're all in the same single Google Cloud project. So we know the total bill for the project, but we have no idea how much the CRM costs versus the website.
Precisely. And if that total bill suddenly jumps by 15%, the owner of the CRM needs to know, was that me? Or was it the data team spinning up a bunch of new machines?
You need to be able to assign responsibility for the costs.
You do. And this is where a really simple but incredibly powerful concept comes in to solve the problem. Labels.
Okay, let's go back to our metaphor.
Okay.
A label sounds like putting a specific sticky note on every single thing in your cloud project.
Yeah.
Every VM, every database.
That's a perfect analogy. Or like a department price tag at a grocery store. The price tag doesn't just say cost $5. It says cost, $5 department, produce. Or in our case, system.crm.
So you're defining the resource by what it's for, not just what it is. So a VM running the CRM gets a label like system.crm.
And the one running the web app gets system.webapp. The simple, consistent tagging is the organizational key that lets you unlock really detailed cost analysis.
Okay, so you put the sticky notes on everything. Now what? What are the technical steps that have to happen next to actually see the costs broken down?
The source material lays out 3 essential steps, and it's all about connecting this organizational idea labels with our analytical engine, BigQuery.
Step 1.
Step 1, assign the labels. The team has to actually go and attach these labels, these sticky notes, to all the resources. It's a bit of manual work up front, but it pays off forever.
And step 2.
Step 2 is the most critical part for FinOps. You have to configure your detailed GCP billing data to be automatically exported directly to BigQuery. This is key. We're not looking at performance logs anymore. We are analyzing the official line-by-line financial records.
The actual bill.
The actual bill. And step 3, query by label. You go into BigQuery, our analysis engine, and you ask it a question like, show me the total cost of everything that has the sticky note system.crm on it from last month.
That sounds almost too simple. Let's dig into step 2 a bit more. When that billing data gets exported to BigQuery, how does it know about my simple little label? How do they get connected?
That's where the design of the billing export is so clever. When you turn on the export, Google creates this huge, very detailed table in BigQuery with every single charge. And crucially, inside that table structure, there is a specific field just for labels.
So it has a column ready and reading for them.
It's ready and waiting. So any label you attach to a resource, like our system.crm label, automatically gets copied into that special label field in the official billing record for that resource.
So it creates this perfectly clear, auditable paper trail. The label is formally part of the financial record.
Exactly. You provide the organization with the label, and the billing system respects that organization when it creates the bill.
Okay, time for some friction. Let's look at the wrong answers. Why can't I just use the standard cost reports in the main GCP console? That seems like the easiest button to click.
The standard console reports are great for a high-level overview, but they often lack the granularity you need for this kind of internal accounting.
What do you mean by granularity?
Well, the console might be great at showing you your total cost for, say, Compute Engine, but if you have 20 different teams all using Compute Engine inside that one project, the console can't easily tell you how much Team A spent versus Team B. It doesn't understand your internal business structure.
But labels give it that understanding.
Labels give you that deep functional granularity that the standard reports just don't have out of the box.
What about the other bad ideas? Some suggested using things like metadata or just the VM names instead of formal labels. That feels like a common workaround someone might try.
It's a very common mistake, and it relies on things that are, frankly, unreliable. One option mentioned using instance metadata. The problem there is that you're trying to query operational data in cloud logging, not financial data. You might guess at the cost, but you need the official billing records for an accurate report.
And just relying on the names of the VMs, like calling it CRM-VM1.
That is so brittle, so fragile. Names change, people make typos. And a naming convention only works for VMs. What about your storage buckets, your databases, your network costs?
Doesn't apply to everything.
It doesn't. But labels are a formal, built-in feature of GCP. They're designed for this. They work on almost every resource type, and they are guaranteed to show up in the billing data. So when you combine formal labels with the formal BigQuery billing export, you get an accurate, reliable, and auditable system for cost reporting. It's the only real solution for serious FinOps.
So the big picture for this cost section is really powerful. Labels give you the organization, the sticky note that defines what something is for. And BigQuery gives you the analysis tool, the powerful library, to ask precise questions about the official financial records. You need both.
You absolutely need both. And what's great is that this system scales perfectly. Whether you have 10 VMs or 10,000, as long as you apply a label when you create it, the cost reporting is already taken care of.
That was a fantastic deep dive.
Yeah.
We've really mapped out the core architecture for two of the most fundamental problems in DevOps,
Mm-hmm.
watching performance and watching the budget. We took what can be confusing exam questions and turned them into a clear blueprint.
Let's do a quick final summary of that blueprint just to lock it in. We have this clear division of labor between the tools.
Go for it.
First, Capture. That's Cloud Operations Suite, specifically logging. It's the high-speed sensor, recording the raw history of everything. Second, Analysis and Aggregation. That's BigQuery, our warehouse or library. You export the raw data there, structure it, and do the complex math like that quarterly summary.
Third, visualization and sharing. That's Looker Studio, our art gallery, the professional translation layer that makes the numbers understandable for the business.
And finally, tying the money side together, cost organization. That's labels, the sticky notes, the tags you put on everything so they show up in the BigQuery billing export, which lets you do that super granular cost analysis.
So you now have a clear map. You have the architecture for handling these two critical tasks using a standard, scalable set of tools. You don't just know what the tools are, you understand why they have to be used in this specific order.
It really is all about understanding what each tool is specialized for. Logging captures, BigQuery analyzes, Looker Studio displays, and labels organize.
So here's a final thought, something for you to chew on after this that kind of connects all these ideas. We focused a lot on how labels are essential for tracking costs, right? Answering, how much did the inventory system cost us last month?
Right. A financial question.
But let's imagine an application that scales up and down automatically. Sometimes it's running 10 VMs, sometimes 100, all based on how many users are on the site.
Okay.
If you're using those same labels, like application.checkout, how could a development team use the performance logs and the utilization data back in BigQuery to measure the efficiency of their code, not just the cost?
That's interesting.
Could they see if a new code release caused the CPU usage for everything labeled application.checkout to spike, even when traffic was low? Could they correlate a label not just to a dollar amount, but to wasted energy?
So you're turning a financial tool into an engineering feedback tool.
Exactly. That deeper connection, linking organizational tags to performance metrics, that's really the next level of cloud optimization. Thank you so much for joining us on this exploration of these essential DevOps data tools.
It was a pleasure.
Until next time, keep digging.